I've got a few projects I've been working on, hopefully videos to come soon, that require tapping a lot of holes. I don't really enjoy the process of hand tapping holes in aluminum and steel. It takes a long time, tires out the forearms, and invariably the results are not always, shall we say, perpendicular. Drill presses and mills can be up to the task, but setup can be time-consuming, and you have to have a mill. With practice, you can use cordless drills to power tap, but it takes practice. I had seen elsewhere on YouTube people using import electric tapping machines. The promise of speed, ease, and repeatability drew me in, so I ordered one. Will this machine deliver on those metrics? Here's what I found out in this tool tryout. This is not a sponsored video. I purchased this tool myself. Full disclosure, it took me 2 tries to get one of these delivered. The first one I ordered just never shipped. I waited 2 weeks, got fed up, and canceled the order, figuring I'd just save some money. Then, after tapping 60 M8 holes in aluminum extrusion, I decided to try it again. This time, the package arrived in 3 days. Although the box is rather large, it's not terribly heavy, coming in just around 70 pounds, and it seems just sturdy enough to survive the shipping trip. Inside, things are packed what I would call well enough. The molded styrofoam keeps things in place, and the bubble wrap is just along for the ride. The unit includes a power cord, some M10 mounting bolts, instruction booklet, a set of torsion chuck quick change collets, a mounting arm, and the tapping machine itself. I ended up building a custom mount for the unit, which I'll cover in the next video. When complete, it'll be linked here. With the base mounted, the height collar is locked in place. Then the tapping arm is lowered onto the pole, the cap is screwed on, and the unit is plugged in. This one runs on 110 volts. With this configuration, the tapping arm has a wide range of motion. The benefit of this long, flexible reach is being able to tap multiple holes without having to reclamp the workpiece. My unit came with 9 ANSI collets and a torsion adjustment wrench. The chuck sizes are 1/16, 5/32, 3/16, 7/32, 1/4, 5/16, 7/16, 3/8, and a half. The literature for the unit specifies M3 to M16 taps. These are all the ones I've identified so far. The tap is simply inserted into the chuck, making sure the squared end of the tap engages in the square cutout. To release the tap, the center plunger is pushed in and the tap will just slide out. The torsion chucks are designed to slip when the torque gets too high so you don't break taps. To adjust the torsion chucks for higher or lower torque limits, the retaining ring is first removed. The included spanner wrench is then used to adjust the setting, clockwise to increase the torque limit, counterclockwise to lower it. Once at the desired setting, the retaining ring is reapplied, making sure the notch in the upper ring lines up with the hole on the side of the chuck body. I had a lot of trouble adjusting the torque settings on the larger chucks. Anything larger than the 5/32 I could not hold the chuck and adjust. In fact, I couldn't even adjust it while it was in a vise. By contrast, here's the 1/16 chuck, which I could loosen easily. Note, I'm not clamping these in the vise. That would certainly mar the shanks. The chuck is just set in with the jaws close enough that the ears catch when trying to adjust. You don't want to scratch these up. I ultimately had to get out the persuader to loosen these units. My assumption is, due to the import nature of these chucks, they may be less than precision. So I thought I'd clean them up a bit in hopes that I'd have a similar result to when I cleaned up the import tool post holders in the Tool Tryout video linked here. The torsion chucks consist of a top adjustment ring, a set of compression washers, the chuck body, the torsion mechanism, and the integrated collet. There are also 3 pins which prohibit the collet from spinning and enable the torsion action to happen. I dropped everything in a degreasing solution suspended in an ultrasonic cleaner and ran a 5-minute cycle. I didn't put the collet assembly into the bath as I was a bit wary of being able to get it properly lubricated again, and besides, it looked pretty clean. If you're enjoying this video, please strike a like and consider subscribing. I'd really appreciate it. With the parts now shiny and clean, I wiped them down well and hit them with some compressed air to make sure to drive out all the moisture. I gave everything a good coating of synthetic grease and began reassembly, starting with the most fiddly part, the torsion mechanism. The key is to make sure the 3 pins are in the correct position and then slide the whole unit into the chuck body without dislodging anything. Also, make certain the uneven side of the torsion ring is facing down. Next are the compression washers. The different size chucks have varying numbers of these washers, and the orientation is very important. If you do this to your set, be certain to take note of how these washers are oriented when you disassemble so that you can get them back together properly. Finally, the adjustment ring is replaced. For all that effort, the payoff was moderate. At least adjustment is possible now, but a vise may still be required for the larger chucks. Once adjusted to your preference, the retaining ring is replaced, again making sure the hole in the chuck wall lines up with the notch in the adjustment ring. Also, just a note, the 2 holes in the side of the chuck enable finer adjustment granularity. Basically, if each notch on the adjustment ring is 1 unit, the second hole allows adjustment down to a half a unit. Okay, that was a lot of messing around. Let's see how this thing works. The torsion chuck is simply snapped into the tapping head. On power up, the unit starts in manual mode. The bottom trigger taps forward, the upper trigger is reverse. My test setup consists of a piece of 3/8 or about 9mm Type 316 stainless steel plate with 4 9mm holes waiting to be tapped to M10. To set up the machine, I select M10 tap size. Note thread pitch is 1.5, which is correct for this tap. I set the feed and rollback speed to 125, the depth to 20mm, and set the mode to automatic. When hand tapping, you usually go in a few turns, then back out one to break the chip. Engaging the deep hole operation emulates this. I also decided to go with 25mm depth to be certain the thread is fully realized. I applied a touch of tap magic, lined up the tap, and hit the forward button to start the procedure. I only kept my hand on the tapping head long enough for the thread to start, then I let go and allowed the threading action to pull the machine downward. If you've ever done this by hand, you'll know that this is very exciting. One beautifully tapped, perpendicular M10 hole. For the next test, I just about doubled the speed to 200. A side note, the touchscreen has a rather small activation area and it's not always easy to get the selection to activate. I often have to try several times to get my selection to register, or I end up hitting a 5 when I wanted a 2. Not the end of the world, just something that gets a bit annoying. Just so cool. Okay, let's see what this thing can really do. Taking the unit out of deep hole operation, I wanted to see if I could just tap straight through using a regular tap. I found it interesting that the machine seems to top out at 375 RPM. If I try to put in a higher number, it just reverts back to 375. Okay, well, let's try this. Yes, we be tapping. You can see by my smile that I like what I see. The threads are just as well formed as the ones tapped at a slower speed, so this is going to be my default from now on. I gotta do that one more time. This time, no tap magic. Sweet. Speed? Check. Ease of use? Check. Repeatability? Check. I certainly liked what I saw. The thought of no longer having to tap holes by hands just lightens my heart and brightens my day. Now, this is a bit of a luxury item and the price reflects that. But if you tap a lot of holes and you want to do them quickly, this is a great addition to the shop. The touchscreen is a little less than optimal and sometimes it takes several tries to enter the information you want, but for me, it's a minor concern. This machine can also be used as a torque-controlled screwdriver, but since my current goal is tapping holes, I'll leave that review for another time. If you have questions or comments, please leave them below and I'll do my best to answer them. I always enjoy hearing from you. Until next time, I'm mainejason with this Tool Tryout. Get out there and give it a try.